Hello everyone. This week we're gonna be covering the purification of benzaldehyde lab. You can find more information about this lab in the textbook in the section 6.4 in the pages 25-26. To start with, let's talk a little bit about the benzaldehyde. The benzaldehyde is an organic molecule. This is the formula as you can see over here. It has an aromatic ring and it has also carbonyl group bound to it. He has also another name that is benzene carboxyldehyde, but it's not commonly used. It's better to use benzaldehyde as it is. This is the molecular formula. The molecular weight is a colorless liquid, and the density is a very important physical property that we're gonna be using for this lab, since when we are talking about extractions, we need to compare the densities between the liquids that we're going to separate. And in this case, the density of this one is 1.044, which is slightly higher than the density of water. That is the other liquid that we're going to be using in this lab. Water has a density of 1. And another important physical property that we're going to be using in this lab is the solubility in water. In this case, this molecule is not soluble in water, so that allows us to use it to use the water to extract and to purify the benzaldehyde. But why do we need to purify benzaldehyde in the first place? We need to purify benzaldehyde because benzaldehyde is a molecule that gets easily oxidized by the oxygen of the air, making benzoic acid, these molecules over here. And this benzoic acid has different properties to the benzaldehyde. So in any water that we have benzaldehyde, we may have some benzoic acid as well. And this is the compound that we are gonna try to get rid of in this experiment. How we gonna do so? We are gonna use sodium carbonate as a base to react with the sample. That the sample is gonna contain benzaldehyde and also benzoic acid, but only the benzoic acid is gonna react with the sodium carbonate, making sodium benzoate and bicarbonate, sodium bicarbonate. These two salts are very water soluble, so in this case, when we add sodium carbonate solution, these two salts are going to go to the water phase, and the benzaldehyde is gonna remain in the organic layer, which make the separation easily to do. This is the procedure that we're going to be following for this experiment. First, we need to prepare a 10% solution of sodium carbonate. We're going to need around 10-15 ml. Usually when we are doing the lab, the TA is the one that is preparing the solution, but you need to know that how to prepare solutions since in general chemistry labs. Then you're gonna take 5 ml of impure benzaldehyde in a separatory funnel, which is this one. This is the type of funnel that we're gonna be using for these extractions. And then you're gonna wash first with 5 ml of sodium carbonate solution. You need to be careful to not shake it crazily. If not, you're gonna make an emulsion, and if you make an emulsion, it gets super hard to separate. Then afterwards, you separate the aqueous layer, which is gonna be on the bottom layer. Then you repeat 3 and 4, so add another 5 ml of sodium carbonate, shake it a little bit, and then separate the aqueous layer that is on the bottom. You're gonna do it one more time. After that, you're gonna wash with water, but in this case the water has less density in this case than the benzaldehyde. So in this case, the water layer is gonna be on the top, and the organic layer also is gonna be on the bottom. So in this case, wash with 5 ml of water, and then separate the aqueous layer that is gonna be on the top. So you need to extract the organic layer, collect the benzaldehyde, and you need to dry over anhydrous magnesium sulfate. After that, you just collect the benzaldehyde by gravity filtration, separating the magnesium sulfate that you get that you use to dry the benzaldehyde. This is just a reminder if you forgot how to use a filter paper. This is how you do the setup for to use it. And this is how you should do the gravity filtration. It's a very easy technique. So once you're done and you did the filtration, you should have pure benzaldehyde. But there is an issue. If you are gonna store this benzaldehyde to use it next week, then the benzaldehyde is gonna be exposed to the air again, and then it's gonna get oxidized to carboxylic acid again, and so we kind of did this experiment for nothing. So to avoid that, we are gonna be using some crystals of hydroquinone, and we're gonna add it to the benzaldehyde. This compound that has this formula is easier to oxidize by the air compared to the benzaldehyde. So in this case, if you add some crystals of this material to the benzaldehyde, if there is any oxidation happening, this molecule is the one that is gonna get oxidized, and the benzaldehyde is gonna remain untouched. And so that's why we are gonna be using hydroquinone to avoid the oxidation of the benzaldehyde. At the end, the waste and chemical disposals, solid waste, we are gonna be having the magnesium sulfate. In the aqueous waste, the aqueous portion from the separatory funnel, and as usual, we are gonna be cleaning the hoods before leaving. That's gonna be for this lab. Thank you so much.